Charles law. So tukumbushane tu what was Boyle's law, and then we'll do one example. We'll do one example of the previous lesson so that we check if we still can remember how to use them. So maybe just to remind ourselves, there was a summary that I gave. Or now we do we state the Boyle's law so that you don't forget. And then there was and then I gave it also for the Charles law before we go for an example so that we see if we can remember or we can recall before we do a combination of the two, which is now called the combined gas laws. So somebody to remind us what was Boyle's law. Maybe even you can even use the idea of what I gave. That is the summary. Yeah? I gave some initials. I don't know if we call it them initials. Maybe somebody can just give us something before we do an example. I think the example that we are going to do, we are going to choose it ourselves. So you choose from question number 3. I think when you do question 3 and 5, that is for Boyle's law. For Charles law, I still have some questions. There is a graph I want us to draw on Charles law, but I think we'll plot it later on. Maybe not today because of time, but I think we can still get time to do that graph. We'll all plot together. I'll send the questions through the group. So Boyle's law, I think I gave something, and then I gave the Charles law. So Boyle's law, we say it is stated using. So giving a relationship between pressure, or somebody can just do that. You can remind us. There's no problem.
Can I try?
Yeah, please try, Monica. There's no problem.
Okay, we said that the volume is inversely proportional to its pressure at a constant temperature.
Yes. Yeah. So we normally say I gave even the summary of Boyle's. So we say B, V, I, P, and then of course now the T is somewhere silent. So that one is okay. So maybe you can even talk about the Charles law before we do an example. We do only one example. And then we go to our combined gas law. We're just reminding ourselves. Of course, I want also to remind ourselves about how it is stated mathematically or how we represent it mathematically. So that one must be done so that it becomes very easy when you're dealing with something else. So we can remind ourselves how it is. So what you have stated, Monica, is true. So we say P1 V1 is equal to P2 V2. I will repeat this one again. This one is the same thing. It doesn't matter how it is stated. Whether you start with V or you start with P, it doesn't matter. Reason being, when you multiply something by another, there is no problem. So it doesn't matter. It doesn't affect anything. So that one is okay. Now, that one is how we represent it mathematically. That one is very important because I don't want us to get confused. Now, let us state about what about Charles law? Let us just state Charles law, and then we represent it mathematically. We might not even do an example now. We can do it later on, but I wanted us to remind ourselves. So when you have this, when you have the formula, it becomes very easy to handle. So it becomes very easy. So that one is for Boyle's law. I will not rub it fast. I want us to continue. We check on Charles law so that we go to combined gas law so that you see what I'm talking about. Huh? So we have Charles law. So Charles law, somebody to remind ourselves. We can just remind ourselves. Somebody just say something on Charles law, and then I'll write the formula, and then we proceed now. But I wanted us to remember the formula because we're going to use it today. We're going to use it again today. Anybody can just give us something. Charles law. What do you remember about Charles law? You don't even have to define the Charles law itself. You can even say its formula was this, something was being kept constant. What was that? Just like that. And then we proceed. We proceed very quickly. And if I move too fast again, you remind me.
The volume is directly proportional to its temperature.
Yes.
At constant pressure.
Yeah. So you must, those things that we underlined the other time, those things that we talked about, those ones that are essentials, those essentials for that actual definition to be true, ni maneno yenye lazima uongeze. We have what we call directly proportional, we have the other one that is inversely proportional. So if you interchange those things, then the formula actually will not be like this. If you interchange, for example, instead of saying inversely proportional, you say directly proportional, it changes the formula. I hope you remember. And if you say something that is kept constant is not kept constant, it also affects that thing differently. So it is very important. So I'm just doing this one for the sake of, because we are going to repeat it there. So we have V1. So because it is directly proportional, it will be over T1 is equivalent to V2 over T2. Remember, the one that is not in the equation, the one that is not in the equation is the one that is kept constant. For example, nini haiko hapa juu ya P1 V1 is equal to P2 V2. Which one is missing? The one that you see is missing. So that one is the one that is kept constant. Tuko sawa? Now, when you move to the other one, which is Charles' law, which is V1 over T1 is equal to V2 over T2, which one is missing?
Pressure.
That one now is the one that is kept constant. That one is very important for you to remember. Now, remember these two equations. I don't want you to forget them because they're using them now. Now, let me just wrap this one and then now we go to what we call the combined gas. Now, Charles' law directly. Boyle's law, is it inverse? Yeah, those ones are very, very important. Don't forget those ones. So Charles' law is directly proportional, and that is where we have those things. But I'm not going to be doing that one today. I want now to go to what you call, we did applications, so we'll still do applications. I want us to go to what you call the combined gas laws. Now, the combined gas laws actually is, like we mentioned at the time, it is combining the two laws. It is combining the Boyle's law and the Charles law. So actually we cannot say this one because one of them is directly proportional, the other one is inversely proportional. That's why I wanted to start from there. So hatuwezi tukastate combined gas laws ama the general gas equation. We are just saying we are combining the two of them where we have the constant. You remember we said P1, V1 is equal to a constant. Alafu kwa Charles law, V1 over T1 is also equal to constant. So we bring the two together, but because V1 and V1 are the same now, it is taken care of. I want you to see. So it is taken care of by that one. So we bring only where, now let me just be writing so that people can understand it. Where the here juu ni Boyle's law and it is equal to K. PIE, I want to change the color. Let me just change the color so that it becomes easier. So let me use yellow today. I don't know. I don't like yellow. So this one is the Charles law and appear is equal to K. So because all of them is equal to K, yeah, because all of them is equal to K, we are saying when the pressure of a gas, the pressure at that moment, its volume at that moment, and the temperature at that moment is zote at that place is equivalent to, as you can see, this one. So I said I don't like yellow. I don't know, yellow is that. I'll change to mine, first of all. Let me just change to mine. Is this yellow or orange? I think it is orange. So let me use my blue, the dark one. So all of these ones now is equivalent to a constant. Now, when you have another one at another place, so we have a different pressure, which is P2, V2, you have kwingine T2, PIE is equal to a constant. Remember, we said a constant is the same. What will be changing? If we change the pressure, if we change the volume, if we change the temperature, the pressure, of course, now in a different place will be changing also. So all of them are equal to a constant, which is, I hope you know the meaning of a constant. So a constant actually is something that has been calculated or it has been tested experimentally. For example, we have the mathematics one. The easiest constant that we know is this one. What have I written? What have I written? Where we normally we used to calculate using it is 22 over 7. So it is a constant like that. So you are calculating 22 over 7. So all the answers will get something that is 22 over 7 or very, very close to 22 over 7. Of course, keeping other things constant, where you could be having human error, you have environmental errors, all of those ones kept constant. So the K will be gotten. I hope you understand it. So this one now, the one that, let me rub this one so that it becomes visible. So the one that you get now, P1 V1 over, where all of them are equal to a constant, is what we call the combined gas laws. So we have combined the two of them, and this one is the combined gas law, where we have P1 is the initial pressure or pressure number 1, yenye inaappear kwa question as pressure 1 is the P1, where we have the initial volume before, of course, adjusting other things, and then we have the initial absolute temperature. Very important to remember absolute. It is very important for you to remember absolute. When I talk about absolute temperature, we are talking about the temperature in Kelvin. Tafadhali msisahau hiyo. The other time I told you you have to forget everything. Don't forget that one. Don't forget that it is the temperature in Kelvin. So the reason why even it is written absolute, I don't think the KLB is writing absolute. KLB haiwaambii in absolute. I don't know, but I'm very sure KLB does not say. So absolute means we are talking about the Kelvin temperature. Atuongelee degrees Celsius. I know we have other units for measuring temperature, which are well known to us or easy to remember. Juu ukienda watu wanapeleka watoto hospitali. Sometimes you go to the hospital, they will never tell you your temperature in the absolute scale. They will always give you in degrees. Unaambiwa uko na 37, so you are normal. Mtoto anaambiwa uko, hata nyinyi mnasema mtoto ako na fever, amefika 40, but you don't say amefika 310 or 333. That is in Kelvin. You say amefika 40. That is in degree. So that is something that we're used to. But that one is not actually the way that is why it must be written as absolute temperature. So equal in Kelvin. Now, for those ones who could have missed the lesson, we will discuss about how it is converted. So even somebody can tell us how we are changing from degrees Celsius, because we are reminding ourselves. So we ready to kumbushane, because we are going to do a question. So 0 degrees or degrees Celsius, not 0, because 0 is absolute 0. We remember. So we have degrees Celsius to Kelvin. We add. I'm just reminding us 273. And then, of course, the vice versa is U minus. So there's no problem. We'll talk about that one. And then you have P2 could be final pressure. Final volume is the last. Now, these questionnaires, when you're given a question on these ones, I'm going to repeat. If I'm moving too fast again, you can mention it. Unaniambia me slow down. Ama nikanyage break, weka speed governor. I think that is okay. So, final temperature. When you're given this questionnaire, I was saying, ukipewa hizi maswali. Now, kwa maswali, what normally happens in the question? Zenye zimeanza, the first ones are number 1. For example, they tell you the pressure, the volume at this pressure and temperature is, so hizo zote zenye zimesemwa hapo ni number 1. Alafu zenye zinakuja nyuma ni number 2. That one, I think students normally get confused sometimes and then they do something wrong. So we'll talk about that one. So the combined gas laws is given that way. So it is very important for you to remember that we are doing the conversion of the temperature from degrees Celsius to Kelvin. So Kelvin is the one that we used to calculate. I told you when we were dealing with Charles' law that any question that comes, na kwa hiyo swali kuna temperature, na kwa hiyo temperature unapaswa kutumia kucalculate, yani ufanye hesabu. The first thing you must do, I'm using your math. If you do not math, or you don't do what I just mentioned, you get it wrong. We'll talk about that one when we cross that bridge. We'll talk about that one. Nataka tu tuendelee tuone. So this one is the formula that we'll be using. I want you to remember the formula for Boyle's law. I want you to remember the formula for Charles' law, and I want you also to remember the formula for what? Combined gas law. We'll talk about that one up chin. There's a question that is normally in the KLB. I hope to get it. If I do, I'll give you that question so that you try. Okay. So we normally have two standard conditions. We have what we call the standard conditions. We have the standard conditions that are subjected to this one, or that affects this one differently. We have what we call the standard conditions. We'll be talking about that one in a few. So remember to change what you're given. Again, I'll repeat that one. Mpaka tumalize this subtopic today. I think we'll be through today. So I'll repeat that one. Please, to me, absolute scale. If you use the absolute scale, it becomes easy. Now, absolute scale and Kelvin scale. Now, we have two standard conditions. Number one is what we call the STP. STP. So sometimes they'll tell you to calculate the STP or calculate the volume at STP. Or they tell you to calculate the STP condition. It is possible. That was the question. I wanted to frame it well. They sometimes ask you to calculate the STP conditions, which in most cases ni ngumu ulizwe hivyo. So most of the time they will use STP. They want you to know what STP means. Now, STP means this. So the standard temperature and pressure, which is normally called STP. So mara mingi utaona imeandikwa STP. Now, I want you to be very keen with the STP in this subtopic, which is in Form 3. When you will be in Form 4, STP will be there. But it will be now the volume at STP. So be very keen. So STP actually is normally 0 degrees Celsius, or the absolute zero. So it is 0 degrees Celsius, which is 273 Kelvin, and 760 millimeter mercury. So STP, we are talking about the standard temperature. So what I'm saying is standard temperature at that particular time. The standard temperature, the 273 Kelvin, or what you call the 0 degrees Celsius. Alafu the standard pressure. So if they tell you to calculate that the volume at STP, that means you already have the temperature and you already have the pressure. You come to Kosawa? I'm going to skip whatever you are being told down there. In the meantime, I'll skip it for a few, but we still come back for it because I want us to. We'll do a calculation on it. Did you come to Kosawa? So that I don't make people feel. I don't make people feel maybe nimeruka vitu zingine. I don't want people to feel bad. Now we have what we call before I come to the other application, I want to look for something else. I'm looking for something else. Don't be worried. I don't know if it is in this place. No, there is no problem. No problem. I'm going to give you that one. So before we go there, we have the standard temperature and pressure, and then we have now the RTP. So RTP, very important. I'm going to write that one down. So we have two standard conditions. We have the STP, which has been mentioned. Yeah. So I'm going to give you another one. I want to write on this side, so I'll just do this. So we have the R dot T P. Yes. Let me check. Somebody is writing something before I continue. So we have two standard conditions. Let me check first before. Okay. There's no problem. I thought it was a comment coming towards the class or about the topic. So this one is room. Let me just allow me to write this one. I thought it was there. Room temperature. Sorry. So I forgot to room temperature. Hii lazima niseme kabisa because it was there. I think it was there in another exam. They were told to calculate the volume at TP. So it becomes problem. Temperature and pressure. So we have STP. I think they assume that we know this one. Yeah? They normally assume, most people but actually do not teach this one. Because we assume, by the way, let me just ask you before even I give my values. What is the room temperature? The room temperature that you normally use in your, maybe when you're doing a practical, muniambie tu room temperature yenye mnatumianga. Somebody, just anybody. I just want to know if people have an idea of what I'm talking about. Yes, anybody who has an idea about the room temperature. This one is something that is very common. Not actually in chemistry. We only have a lot of this. So let me check if somebody has written something in. James is saying 37. Yeah,
25.
I want to answer. That is Maura. Maura is saying 25. James amesema 37. Everybody is correct actually. Everybody is correct. Now, the room temperature that we normally use most of the times, if you are in the southern part of Kenya, a southern part, I know when I say northern part, like in Wajir, in Turkana and the rest, the room temperature we normally assume to be something running from, I know if somebody has written something, running from 20, 27, I don't know, depending on where you are, depending on for example, now in January, the room temperature will be something different. Sometimes when you're doing exam, it is raining, so the room temperature will be. That is why it is very important for you to measure the temperature. Ukifanya practical, usiandike 25. Let me repeat that statement very slowly. Ukifanya practical, na waseme measure the temperature at which that solution is in. Solution yenye hiyo, the temperature in which that solution is in at that particular time. Now, students normally ask, sasa wakimark watajuaje my temperature was 17. Sasa mwalimu na wanatuambianga ni 25. So there is what you call the school value. I don't know if you have ever heard of what you call school value. So mwalimu pia anafanya practical at the same time you are doing, or where you are doing. I don't know, in your center now of the exam, there's somebody else who is doing that practical. And when they do the practical, they'll measure the room temperature. Na juu ilikuwa inanyesha pali huko, labda ikuwe 17 ama 18, na wewe ukaandika 25 na mwalimu akaandika 18, you'll wrong that answer because they assume the teacher now or the person who did the practical is right. So it is very important for you to use. You do not assume that the room temperature is. So actually, James, welcome very much, James. Nimeona umekaribishwa kwa chat. I have to also welcome you. Now, the temperature that James gave me is 37. Now, that is the room temperature of the body. Let me say, even temperature, we assume that for you to be healthy, you are supposed to be having a temperature of around 37. Ikienda 39, 40, they say you have a fever. That is a temperature imeenda juu, and it is very dangerous. So the temperature that I've given me is, so the room temperature in almost 70% of the world, keeping everything constant, is normally given as 25 degrees. So we'll have 25 degrees. I want people to give me this one now in Kelvin. In Kelvin, 25 degrees Celsius in Kelvin, so that I stock and then I write there. So what is 25 degrees Celsius in Kelvin? So that you know the RTP. Sorry?
298 Kelvin.
Tell them how you got 298, please. So that I don't nisimalize mate peke yangu and you all of you are aware.
Okay, I have added 273 in 25 degrees.
Yes. That one is how you convert it. And now the room temperature in absolute scale is 298. Now, when you talk about the pressure does not change. Now, we know the factors that affect pressure, but we are not going to mention them in this level but we are not going to mention them in this subject to be specific. We don't talk about factors affecting pressure in chemistry. It goes to another subject. It is taken care of by another subject. So I'm not going to mention that one. So the pressure actually remains the same, 760, and we use 760 most of the times. So you should not be worried about where these ones are coming from. I wanted to give you the standard conditions first, so that before even we solve, we will see. So standard condition number one is the standard temperature and pressure, which is normally abbreviated as STP, which is 273 Kelvin or 0 degrees Celsius. And this one has already been converted. So you're adding 273 to 0 becomes 273. And 760 mm a G or millimeter mercury. Now, when you talk about another standard condition, I said we have two standard conditions. We have the room temperature and pressure. And the room temperature, I've given you the value. So it is very important for you to know the values. Because sometimes I might not give you in the question. I assume that you know that I taught you something on the standard words, conditions. So you're supposed to know. Yeah. So how you calculate that one, there is no problem. This one, they're only showing you how to do it, which I don't normally teach that one because of confusion that normally occurs. I'll not teach you how you calculate that one. So what I do, I skip directly to now a calculation because I needed to tell you we have standard conditions. Tafadhali weka hiyo kwa akili, the two standard conditions. Sometimes I might not give you, but I'll tell you to calculate the volume at a standard condition. Applications of combined gas laws. So application, so example number one, I'll do example number one. I give you about 5 minutes, you do example number two. I see if people have understood. And then we do another one. We can even do four. For the sake of, so I do one, you do one. I do number three, then we do number four, and then we see kama tumeelewa. We end it there, we go to another subtopic. If not, then we do more for better under. I would like people to understand this one because most of the time gas laws you never miss because it is a calculation one. And the bad thing about gas laws, I don't know if it is bad or good. Actually, gas laws does not qualify for the practical, especially these calculations. So it must be there because it is one of the calculations. In Form 3, it is one of the topics that has calculation. You have only two topics that have calculations in Form 3, which is gas laws and the mole, which is the next topic. So most probably you'll have a question on this. Now, so example number one, we say a certain mass of gas occupies 400 centimeters cube at 25 degrees Celsius and 760 millimeter mercury. What will be its volume at, if I was a person setting this question, I would have given you this one. I want people to tell me what that one means. What will be its volume at 0 degrees and 740? So I would have changed mine. I'll tell you how I would have changed. I would have said, what will be its volume? Okay, let us solve this and then I said that one with trials. So what will be its volume at 0 degrees Celsius and 740? So the first things first, you choose or you identify the variables. That is how we solve this. We are still doing the calculation. So kitu ya kwanza una identify variables. So unasema 400. So we identify number one, you identify 400. That one you say ni nini. You go to another one. You identify 25. Unasema ni nini. You identify, and then remember when you're doing a calculation, lazima ufanye na nini? Absolute scale. So you must convert what has been converted. So it is very important to remember that one. So let us see how we're doing it. So number one, you identify the variables. So we have identified, we have P1, pressure 1, that is, which is 760 in that case. We have volume 1, 400. Remember what I said when we were dealing with that one. The first things hapa, what I was saying now, ile vitu nilikuwa nasema, hizi za kwanza zote zina fall under 1111. So you say it is either pressure 1, volume 1, temperature 1. Yani zenye zimeanziwa kwa question, that is how the question will be. The first one to come before the full stop or before the other comments, before the other what do you call it? Is it hizi vitu commas na nini zinaitwangaje? Anything that comes before that is 1. So don't interchange. Now, I had mentioned earlier, when you're dealing with the other two laws, I had mentioned that the units will guide you in identifying whether you're dealing with pressure. Do nilipeana units of pressure, which we have around 3. We have the millimeter mercury or the centimeter mercury, which is the same thing. We are only changing, and the meter mercury. That one is the same. It is talking about mm a G, cm a G, or m a G. Hiyo haina shida. We have what you call the Pascal. Ukiona Pascal ni pressure. If you see newtons per meter square, the pressure. That is why I had to do it before we handle this one. I'm just repeating for the sake. Anytime you see now centimeters cube, we have meter cube, we have milliliters, we have liters, and anything that is cubed, and then we have the common ones zenye tunatumia nyumbani. Liters, unaenda unasema leta maziwa 1 liter, those ones are still volumes. So msisahau hizo. Sometimes I could give you the mass, and then I give you the density. So I also took care of that one, where we have density is equal to mass over volume. So that one is taken care of. So I'm saying the unit should guide you. Now, another thing about temperature, we have 2 units of temperature, main ones that we do, which is the degrees Celsius and the Kelvin. So remember, sisi sasa tunatumia nini? Degrees Celsius. If the question is in degrees Celsius, you should be worried because that one is not complete. But if the question is in Kelvin, they have simplified for you. So we continue. I was just touching on that one for to sisahau. So this one, pressure 1, 760. Volume. Now temperature 1 is in, it is in degrees Celsius, but we cannot calculate. That is why you see now we had 273, so that we have 298, which will help us. Now, so we continue. We go to pressure 2. So we have pressure 2 here. Pressure 2 is 740. And then what are we looking for? What will be its volume? So V2, we don't know. And then we have temperature 2. But remember, again, you convert. So 0 degrees Celsius, we get it to the absolute scale. So the absolute scale is 270. After you are done with that one, you just go now to writing the formula. So you write the formula. I don't want this one. Now I'm repeating this one. Please don't solve it the way it has been solved. If let me just do it. Please don't use this. Don't use that. The reason I'm saying don't use that, you will see what will happen. So you just write the formula P1 V1 over T1 is equal to P2 V2. I'm advocating for not using that one directly. The summarized version. The summarized version can bring problems. Now, if you have done enough practice and you can remember everything that you have just mentioned, you can use the summarized version. But I'll prefer people to use this one, where we now replace P1 with 760, V1 with 4, and then T1 that one. Now we have P2 unakuja una replace na yake, which is 740, and then we have T2. So when you replace now, I will advocate for you to do what is done down. You can cross multiply. So you cross multiply this way, hour and hour, hour and hour. So we'll have P1 V1 T2, that is because multiplication is equal to P2. It will end up the same way, but it is better to be safe than sorry. That is what I'm saying. P2 V2 T1, alafu una divide sasa P2 na T1 hapa, alafu pia inakuja this side P2 na T1. So this, and this go. So you end up getting this one, but you don't start from there. If you are very sure that you can remember starting from this place, this one, which I have cancelled, then you do that. But it is very risky. Again, that is why I don't advocate. Kama nyinyi mnaona aje, I want feedback so that people cannot say naleta vitu alafu mtu anajua kama naleta vitu alafu nazichange. I don't know if which one is better. Do you think you can go directly to this one or because sometimes you can ukuwa umeshika hii alafu problem ipatikane you are looking for V1, so sometimes it can bring confusion, but the summarize all that, this one is the summary of all of that. So it is better to kushika the actual formula than to come and alafu manipulate the formula than to kushika yenye imekuwa manipulated. I don't know if that one is okay. So you now remember something else I almost forgot when I was talking. Don't cancel out don't leave out when you're writing that one. So unaona hii imeandikwa 760 millimeter mercury, 400 centimeters cube. I don't know if somebody is saying something. So James is seconding, saying your way is better to avoid confusion. So yeah, to avoid confusion, and we are looking for these marks. Now, 2 marks in an exam, the KCSE can change your grade from C to C plus. I hope you are aware of that one. 1 point, that is scoring C instead of C minus, can help you get a better grade. So very, very important. So it is better to uandike. In fact, when somebody writes this one, hata upotee venye kufanya, you already have a mark up, 1 mark. This one, I don't know if I'll give you a mark because this one is a solved one, but I wanted the actual formula for combined gas flows. Now, and something else, let me wrap because tumefanyia hesabu. If you need the whiteboard, we can use the whiteboard. But I was thinking because these ones are questions that we are following, it is better this way. So kitu nilikuwa nasema ni don't cancel out, don't remove the units before you have the answer. For example, so utoe hour wamatoka. Remember this one is K. I want you to remember this one is K. So the K and the K goes. So what remains, it will guide you to know what you are calculating. So that time ingine pia you're moving too fast. So sometimes you might forget what you're calculating. Ukuja uandike 376.3 Kelvin, which makes that answer now wrong. So don't cancel out the ones that remain or the units that will remain. Uandike kama ni centimeters, unaandika hata kwanza. The answer, that is how I normally write. The answer is centimeters is equal to centimeters cube na niwache hivi alafu kuja niandike sasa my 376. Now I want to tell you something. Sometimes the questions that are given in combined gas laws are not being used to solve combined gas laws. I'll repeat. Sometimes questions ziko hapa, especially in the exam, if I want to confuse the students, I'll tell you the temperature is 0 degrees and the other temperature is 0 degrees. Do I have to even use this one? So no, the temperature actually is constant. So you look for a question or the formula that was saying the temperature is kept what? Constant. We'll see more examples. Sijui kama watu wameelewa kidogo, because we are still doing examples, so you should not be worried. We are still doing an example. So I normally check the charts always. Example number 2. Can you try this? Now, remember vitu nilikuwa nimesema sasa, ile in an class experiment it was found that a gas occupies pm cubed. Ikikuwa cubed, it is volume. So watu wajaribu hiyo. Let me just give you 5 minutes. 5. Hata 5 si mingi. Let me give you 5. Let me give you 5. 5. Please let us try that one. If you have a problem, you chat me or you say something. I'll mute myself also for that 5 minutes. So by 8:50 we should be done. in a class experiment, it was found that a gas occupied 48 dm cubed at 25 degrees and 2 atmospheres. What volume will it occupy at ST? I like this question. I like this question na ni vizuri hata sikufanya imekuja kwenu. You'll tell me that one at STP. Somebody said something? So I have one answer, but I want people. If we get two answers, the better, so that I can. I'll solve it. I'll solve that question. It's very interesting. It's a very good one. Then we'll set another one so that people can check. I have one answer. If I get 2, I continue. And remember, time is done. 5 minutes is enough, actually. It is a lot. Remember, you are supposed to answer 80 marks. That means around 30 questions in 2 hours. I don't know if we continue or let me continue. I have only one answer so far, so we'll use that one. James gave us
1 minute. Teacher, give
okay,
me one
okay,
more
okay.
minute.
Okay, no problem. At least you yeah, ukiona nataka kuendelea na hujamaliza na unataka kuona how you are faring on, please unaniambia tu. There's no problem.
$87.9. Mine.
Yeah. 87.9. 87.9. Yeah. So I think you're almost
Mine,
yes, Monica.
mine is 244.8.
I want now something like that. The reason why I wanted people to handle is so that I can have different. I have to write that one down. Please, a few minutes. Let me look for a pen. I didn't have a pen here. Now I do have a pencil. So we have 87.98 dm cubed. I think this one becomes now James's and Monica. You're saying 200.
244.8.
244.8 dm cubed. Yeah, it is also all of them are dm cubed. Yeah. So now that we are done with that, now let us solve this question together, all of us. Now I normally like people doing them so that I get different answers. I normally enjoy the class when I get different answers. It is more interesting than getting the same answer. Actually, it is boring to get the same answers. Because if you get the same answers and all of them are correct, well and good. That means people have understood. But when you get different answers, that means learning is going on. That's what I normally tell my students. So that means learning is going on. And when you try, it is better to try and get it wrong than to assume that the other people will solve it for you. So let us check this out. So in an experiment, in a class experiment, it was found that a gas occupied 40. So we have 48 dm cubed at 25 degrees Celsius and 2 atmospheres of pressure. So that one is another. So this one actually has given us another unit. So we have different units for measurement. So we have dm cubed. So this one you'll have. This one is I don't know if somebody has written something. So we have V1. We have T1. I'll check it. And then we have P1. Let me check before we continue. So that is okay. Maybe somebody has written something. Okay. So it is okay. It is okay. So I think 98. So the other one is 87.995 dm cube. I think we have two that are very close. So it is okay. Yeah, it was Maura. Okay, thank you very much, Maura. Thank you everyone who participated in trying this question. That is James and Monica. Now we continue. Now, what will be the volume that it will occupy at STP? So the first thing of knowing. So we have identified P1, we have identified V1, we have identified T1. Now we want P1, P2, we want also T2, but we have been given in the question. So the one that we have not been given is V2. Yenye sasa tunauliza ni gani? So you find, so pressure, what was the pressure at STP? Remember I gave you the standard condition. So I give you the standard condition, which I say STP, which is the standard pressure and temperature. And then we have the RTP, which was the room. Those are different standard conditions. We have two standard conditions. We have the STP, which is the standard temperature and pressure. And then we have the RTP, which is the standard, the room. S is for standard. We have the RTP, which is the room temperature and pressure. Now, so because ours is talking about STP, we know that STP pressure is, so you are supposed to do this. So it is 760. I knew where the problem would come, by the way. This one is the interesting. We know that it is 760 mmHg. I'll show you how it is converted. So that is very easy. And then we have the STP, the standard temperature is 0 degrees Celsius, which is also called the 273. I just want to explain before we move down. Now, remember, so we have 2 atmospheres. So there's a problem with this question. The units that are here, I showed you how to change them the other time. So I don't know if people still remember. The units that are in the pressure and the units of pressure too are different. And if they are different, you cannot calculate with different units. The units must be same so that you cancel out, remember. Now, there's no problem. So temperature 2, you must also convert by adding 273, which now becomes the room temperature. So it's 298 Kelvin. Now the space that I have is small. So after you have identified all those ones, you have identified the pressure, the temperature, and the rest. Remember, one thing now comes in. This one, the units burner. The units is different. The units of atmosphere and that one is different. I had given the way of calculating many atmospheres and the rest. So I don't know if people still remember. Do you still remember how to convert? Before even I continue and convert them for you. Do you still remember how it was converted? So the same thing is happening. Now, before do you still remember how it was converted? I want you to go back. Yeah, let me just do it now. Yeah, before we, let me do it here. The conversion that we did mostly actually was one atmosphere is the same as one pressure. Actually, in one pressure, one is equal to 1 Newton per meter square. I just want to convert for the sake of, and then it is equal to 1 Newton. In physics now we teach this one. We teach even how it is calculated. The Paka Upat is equivalent to 760 millimeter mercury. So you can convert it. You can choose to come from the 2 atmospheres to upper, ama urudi from this place to, so itakuwaje? Which one is better? You choose the simplest one. Ubadilisha equal 760 ama ubadilisha equal 1. Because we know that, I think I should have mentioned that one. I must have forgotten. I should have mentioned it in the standard, in the STP. This one I should have made, but I the only problem is we did it the other time. No, we converted it to this one the other time. But maybe we just do it. There's no problem. So gani ni rahisi tukuje hivi ama tuende kwa 760? Because we already know. Yes.
Kwa
We
760.
go back to the one.
So we can do both of them. Can we do both of them for the sake of taking care of the difference? Do both of them. So
Yes.
I've given you. So nimewapea hii. Remember that one. So 2 atmospheres. So if I want to change now 2 atmospheres, so the pressure one, so that I have pressure 1. So 2 atmospheres ni ngapi? So you do the cross multiplication, you know that. So ni ngapi? We are not talking about even this one. We don't care about this one because it is not touching us as per this question. So we just assume that haiko hapo katikati. That is why I've crossed it there. I've placed an X. So ni ngapi? And you do the cross multiplication. Huyu akuje na multiply na huyu na over 1. So inakuwa 2 multiply atmospheres. I normally write everything that is in the in the question, sorry, multiply by 760 millimeter a g over 1. I write everything so that it tells me. It is, I'm helping myself when I write everything rather than, so 1 atmosphere. So the atmosphere, so whatever remains is in millimeter. Okay, so what is 2 atmospheres in millimeter? So I have to wrap this one again. That's why I wanted a whiteboard, but I'll share the whiteboard. Maybe tukipata question ile moto kabisa, we use the whiteboard rather than kuandika na kurab the same page. So what is the 2 multiplied by 760?
1520.
Yeah, okay, thank you, Monica. I don't have a calculator, so mtakuwa mnanisaidia. 1520 millimeter mercury. Iko sawa. So we have everything. So we identify. So we P1 is 1520. Now, excuse me, I might not use the units, but I will advise you to use the units. I might not use the units during your space. Iko sawa. So, but please make sure that you have written the units so that you don't forget, that you don't get confused. So nitawacha units juu ya time pia kuandika, because I'm using the cursor in there. I'm not using a touch screen. So if it was a touch screen, it would have been easier. But again, touch screen has its own issues because I'll be using my actual handwriting. And sometimes naona handwriting yangu inaweza kuwa ndogo, watu wengine wanaweza shindwa kuona. So let me just get rid of the units for now. But I'll show you the question hapo chini. So we have 1520 as pressure 1. And then you multiply by volume 1 ngapi? 48. Sindio? 48 over the temperature 1. So temperature 1 is 25 degrees, but you don't calculate using 25. So kama umeona kabisa umeshikwa na time, you can do this 25 plus 2, 7, 3. But I would advise you to convert. Ikiumana kabisa, you do this. Is equivalent to STP. The pressure at STP equals 760. We had identified. I hope people can remember. 760 multiplied by volume. What volume? So we do not know volume 2. No, watch here. And then over the temperature. So temperature 2 ni standard temperature, which was 0. So ni 0 plus 273. And then you close the bracket. So this one becomes easy. So una cross multiply, hour wanakuja hapa na hour wana multiply na hour. So it becomes 1520. Let me wrap this one. Let me wrap the 15 because we already know that it is 1520, so that I can use that space. So we have 1520. And then I multiply by 48. And then you multiply again by 273. Let me just do it directly. Okay, or we can say E is equivalent to 760. And then you multiply by V2. And then you also multiply by 290. By 298. Multiply by 298. So tukishafanya hivyo, so you look now for the simplest one. Pali kuna unknown, you divide the rest now. So over 760 multiplied by 298 over 760, then you multiply by 298. And then, of course, the 298 and the 298 goes away. I want you to see this one. So this 760 and 760 inatoka. 298, 298 inaenda. So what remains is 1520 multiplied by 48 multiplied by 273 divided by 760 divided by 298. Yeah. I hope you have understood what I just mentioned. So somebody to please help us. Somebody to help us now in the division. We have 1520.
Teacher, before you continue,
Yes, please.
where you have cancelled 298 and 298.
Yeah, on the other side, nimecancel za huko. Now is equivalent to.
Or the
So
other side.
nimecancel is 760 na 760. This one and this one. So that I remain with the only thing that is remaining on that side is V2. Now, which is equivalent to 1520. Let me write it on top here so that for the sake of visibility. Yeah? So what is remaining in that question is V2. After nimecancel V2 ndo inabaki peke yake on the other side. So I make it the subject of the formula, so inakuwa V2 is equal to 1520. What I want now, Mauro, is this 1520. You multiply by 48. So if we solve this one, the same, we can solve the other one also, but I think the other one now has been solved in the question by 273. But the answer must be the same. If we get a different answer, then we are wrong. 760. You multiply by 298. So what is the answer to V2? Now remember, you just go now because yangu niliwacha units because of time, I'll just write the answer should be in dm cubed. So my answer must be in dm cubed. So now because I don't have a calculator, I wait for you.
I'm getting 87.9.
So 87.9. Anybody else who has a different answer? 87.9. Does it have other things, other decimals or something?
Yes, 87.946.
46. Anybody else with a different answer from that one? Anyone else with a different answer from 87.96 or 946 or 95 in that case? Kuna mtu akona jibu tofauti, that one is the same answer. So when you use now the millimeter mercury, this one is the answer that we get. I want us to keep in mind that answer before we go to the next now solution. So the answer that we got, kuna mtu alikuwa amepata hii, si ndio? I think we got this one. Two people could have scored this one correctly. Now I want Monica to tell me what could have been the problem first before we continue. I think Monica, you had given us an answer.
Yeah, I know a mistake. I know.
You have not really made.
I was confused because I didn't know the standard. The standard temperature, but you have shown us. Now I can do it. Again.
Now I want to do this again.
Then I have a
before
question,
I continue. Please ask.
You have talked about the room temperature to be 298, but hapa sioni penye umeitumia hata kidogo, so I'm still confused, but nimeelewa vile umefanya hapa. But sasa
this one wametuuliza STP. Now the question could be, what volume will it occupy at RTP, which is the room temperature? We have two. I want to go back there first and then we continue. Can I go back there for the sake of Monica? Let me wrap this one and then we go. Yes, let me do that. So tumepata answer tukitumia in millimeter mercury. Let me rub this one and then so that isitusumbue tukiwa huko juu kidogo very quickly. I want people to understand. The other time I said eri tuende polepole na watu washike hiyo kidogo, then we move as fast as we can. So I'm going. So there is a place. Yeah. Hapa. Monica, mark this one very well. Kuna place nilisema we have standard conditions when you are calculating the combined, or when we are utilizing the combined gas flows. We have two standard conditions. Number one, nikasema ni standard temperature and pressure, which ndio hii. Let me just highlight that one, which is abbreviated as STP, and the values of these ones ni ndio hiyo 273 Kelvin, that is STP, ile STP abbreviation, and 7 hapo huko sawa Monica?
Yes.
Now nikasema there's something that has not been written in these notes, which we call now the RTP. So we have two standard conditions. These ones are standard conditions. Standard. So standard conditions. Let me just do this one for the sake. Standard conditions. So we have two standard conditions that we study in combined gases. Number one, that is number one. We have number two now, which yenye umeulizia sasa, which you call the RTP. Yes. Room temperature. Let me just write in full. Let me not go through shortcuts for better. Room temperature. We call what we call room temperature and pressure. We have room temperature and pressure. Now the room temperature in our case is 25 degrees. Na nikauliza watu, I think the person who converted this one was Mauve. So nikasema when you convert 25 degrees to Kelvin inakuwa 298. I want you to internalize this one, because another question, the reason why the other one was that way, the question was asking about STP, we could be getting something else that is asking about 298 Kelvin. Na nikasema the room pressure is not affected. It is the same as the standard pressure. So this one again, it remains as 760 millimeter. So we have two standard conditions. The only thing that they didn't mention is the RTP. Now they did give us the standard temperature, which is the STP. Hawakutuambia maneno ya RTP. Sijui kama tuko sawa Monica sasa?
Yes. No.
So our question was not touching on RTP anywhere, or the room temperature and pressure. That one can come in another question. So anytime nilikuwa nimewambia wanaweza kuambia calculate the volume at STP. You see, now that was the question that we solved. So anytime it comes, you don't have to be worried. You are supposed to know those standard conditions. So the standard conditions is here. RTP 25 degrees, you can convert, which is also 298 Kelvin. And the standard, or the room pressure is 760. Room temperature, 25 degrees. Room pressure, 760. Standard temperature is 0 degrees Celsius, which is the same as 273 Kelvin. And then the standard pressure is the same as room pressure. So those are very important. So which is this one? So when they tell you to do something, solve it at STP, you are using 273 Kelvin and 760. If they say solve for the volume at RTP, you are using 298 Kelvin and 760 millimeter mercury. Iko sawa mpaka hapo. So that we go to, yes. Now, I knew that the standard conditions, I was very sure it would bring problems, but it is okay. At least you brought it up as early as now, before we move to something a little bit technical. So, now to just how, so it's still fresh. I must say, if you have a question, it is better to bring it now when you're solving that topic or when you're solving that one. So, let us see now it is solved the other way. So, the answer that we got was 87.9 something. So, when we do that, if we use now the 1 atmosphere, let us see if we are getting the same answer. I don't know. So the same answer is gotten when we use atmosphere. You see now, what is happening here? Let me highlight. I'll be highlighting and then you see pressure 1, 2 atmospheres. The volume is okay. So we have now pressure 2 is 1 atmosphere. Lakini sisi hatukusema ni 1 atmosphere. You remember we use 760. So we use 760 instead. And then we use 273. Of course, it remains unchanged because it is. I don't know. I think James can explain this one. James, how did you solve yours? Is James still in? I hope he is. I really wish he is. If he can speak, I need him to speak. Because Mwaura, again, I think you got the same answer. I don't know if you can talk. Please say something about, did you use this one or the other one?
The temperature.
No, I'm saying, how did you solve yours? Did you use the 1 atmosphere or you
I used the 1 atmosphere.
So you knew
For
how
the
to
P2,
convert
for the
this one?
P2.
Yes, you
Yeah,
knew how
for
to
the
convert it?
Yes.
Okay, okay. That one is, I'm really happy that, so you have 1 atmosphere and then you just equate, you get it that way, and then you still get the same answer. Did you get the same, did you get 87.9 by the way?
Yes, me I got 87.946. Then I put it in 2 decimals, 87.95.
So you just round off, yeah? So,
Yeah.
okay, so James is telling me again, Altimia wanted. That means people had an idea of how it is converted, which is good. I think I'm happy people had an idea of how to convert this one. I'm happy. Now, for the sake so that we come at par, all of us, can we try example number 3? Tujaribu 3 tuone. Alafu tumalizia hapo. I think we can do something else. I'll give you something to try. I'll also send something for you to. Yes. Jaribuni hiyo. I think you can try this one, Niwache mujaribu hii pia. So certain mass of gas occupies 220 at 18 degrees Celsius and 7. At what temperature will? Yeah, I like this one. I will add the question. Can I add? I'll add a question. I'll add the question. Just complete kwanza alafu. I add a question which we do it alafu we complete for today. This subtopic. And then we do now something else. Which I want to introduce a little bit of something. Which the reason why we have dealt with this one so much, I think, is because of the STP and the RTP. But it is okay, kama umeelewa hiyo, and please don't forget that one. Sorry. Yes. So I've given you the formula. So let me just mute and then I leave it first. I think we are getting answers, so I didn't want to rush you. So James has given us some. So we have one answer actually, but it is good for you to know how to solve it. So we have one answer. So let me just give. I wait for maybe two people or even one, so that we have a comparison. To get the same answer, the better. I says the mind. Kwanza tukipata answer moja correct, the better. Saves us time also. But that is how we solve this. That is how you should know how to solve. That is how we solve those questions. It is very important.
Sir, mine is 247 point
Yes.
247.74.
247.74. Remember to give the units, please. Kelvin or degree Celsius?
Kelvin.
So I think so. Okay. So James has given me also another answer. Daniel, are you okay?
Me teacher, nimepata 247.74 Kelvin. I have written
Yes.
my answer.
Yeah, I can see your answer. I don't know if I still give you a few minutes, Monica.
No, that is my answer, sir. I can't change. I know it is right.
Oh, I like the confidence. I like the confidence. So, now let us check how it is solved. So the first thing you must identify. We say we identify the variables. That was number one. So we have the variables, and then the variables have a problem. So we have the pressure, we have the volume. Remember, you should always change the temperature to the Kelvin scale, or what you call the absolute scale. In that case, and then we do that. So the answer is 247.7. Now I want to give the question continuation of that question and say give the answer in degree Celsius. Can you give us the answer in degree Celsius? I'm interested in knowing the degree Celsius. Give the answer in degree Celsius before we go to something else. Give the answer in degree Celsius. Give the answer in degree Celsius. Give the answer in degree Celsius. So that we finish. Yani tuunde ile ya kwanza and then something. So that I think we can go to something else.
Negative 25.3 degrees Celsius.
Negative 25.3 degrees Celsius. Somebody else with a different answer?
I support her. Mine is 25, negative 25 degrees Celsius.
Okay, so Monica, we have the same answer with Mauro. James, I've got something to say, even on the chat. I don't think you can just post it on the chat. And then we call it, I think let me call it a combined gas law. But I want to do one question. Can we do one question which I will be changing so that people can understand what I want to see if people have gotten the same. If you've gotten the same answer, most probably all of you are right. Is it positive or negative? James. 25.3? Yeah. So if you've gotten 25.3 and a negative sign, then you are good to go. I think you know now how to do those things. So we are done there. Now I want to do one. I want to change a question. I want to go back to something. The same page, but I'm changing something alafu mujaribu pia, so that I see if people could recall. Now I want to change this question this way. So I'll just change a few things. I'll just change a few things. I'll change this one. Maybe I put 80 dm cubed. I change this one to say 50 degrees Celsius. And then 2 atmospheres. Let us just leave that one. And then I remove the S. That's one and make R. Can we try this? I don't even know the answer myself. I'll do it also. So it is in a class experiment, it was found that a gas occupied 8 dm cubed at 50 degrees Celsius and 2 atmospheres. What volume will it occupy at RTP? So instead of S, RTP, at room temperature and pressure. I don't even know the answer at a minute, so I'll do it also. And then that one becomes the last question of combined gas laws. Kama hujaelewa kabisa, now you come privately. You look for me, I'll help you. Some people have sent me good graphs, actually very good graphs. Like naweza tumia kumark ya watu wengine. So the graph that I've gotten, it is so good that ni kama nimeundiwa marking schema. That's what I'm saying. So remember to RTP. So I just wanted people to shake RTP. I think I could continue without talking about that one. I hope everybody have understood the question. I hope people understood the question. As I'm saying, the question is in a class experiment, it was found that a gas occupies 8 dm cubed at 50 degrees Celsius and 2 atmospheres pressure. What volume would it occupy at RTP? We're just changing a few things. What volume will it occupy at RTP? RTP. What volume will it occupy at RTP? And then we go to something else. I was thinking, nilikuwa nafikiri tutafika Graham's law of diffusion, but it's okay. I think we can still manage. You still have around how many minutes? Huh? Time is moving very really quickly. But watu waelewe tu. That's very important for me. And I think it should be also for you. In a class experiment, it was found that a gas occupies 8 dm cubed or dm cube at 50 degrees Celsius and 2 atmospheres pressure. What volume will it occupy at STP? At STP. At STP. I think answers are starting to stream in. Tutafanya wote hapa so that people. So I'm getting one answer has already come in. So we have 92, 92.26 dm cube. Yeah, let me just. Can I give you a minute also the rest so that you see? Try.
Yes, acha tumalizie.
Okay, no problem. So I think I got another answer. So we check all of us. This one is interesting. Getting two different answers. 147.62. Okay, so we have 147.62 dm cubed. Yeah, so Monica, you requested for a minute. I'm giving you that.
Uh, 147.6 dmq.
Okay, so we have, okay. So can we solve it? I think we should solve it because you have two different answers, which makes it interesting. So that means lazima to solve. Now, so what we do, first of all, we do the same thing. We identify the variables. We say 80 is V1. So we have 50 to be T1. And then we have 2 atmospheres. Sorry about that line. There's a problem. This one now becomes P1. So we have already identified the variables. Now, remember, one variable is not in the good units for calculation. So which is temperature. So you add 2, 7, and 3. So the temperature one will be ngapi? 3. Let me confirm. Yeah, 323. I hope that is okay. Okay, Kelvin. Now, when you go to the room temperature and pressure, the room temperature, so we have temperature T2 now is the room temperature, which tulisema 25 degrees Celsius, which is also called 298. So you had 273 or 298 Kelvin. And then we have the pressure in our case. So to call to Mesema, you can convert the other way. So let us convert it to the easiest one. 1 atmosphere is equal to 760. Now pressure is 760. So pressure is 760 mmHg, which is millimeter mercury. Which is also called 1 atmosphere. So I would prefer we use 1 atmosphere because of time and because of course it is the simplest to divide. So we have P1 is 2 mbili, V is 80 over T1, which is 323, is equivalent to P2 ni ngapi? 1. It is 1 in our case. And then multiply by yenye hatujui sasa V2 over the temperature, which we know 298. So you cross multiply hawa wanakuja, you multiply by that one, and then this one you multiply by this one. So you do this way. So it is 2 multiplied by 80. You multiply by 298 is equivalent to 1 multiplied by V2. You multiply by 320 by 3, 2, 3. And then you divide. So over 323 multiply by 1, lazima niweke hiyo 1 due time hiyo 1 na equal, there will be something else. So I must show you that you divide by all of them. 1 multiplied by 3, 2, 3. So huyu na huyu anaenda, huyu na huyu anaenda. So we have V2 to be equal to. So this one now you just feed into the calculator. So which one is the right answer now? Between 92 and 147. Which one becomes the right answer from what we have done there? Which one becomes the right answer? So you just fill in the calculator. But the answer is, it is in volume. It is the volume. So it is in dm cubed. Please pray that they don't tell you to give the answer in liters. Or you pray that they don't tell you to convert the unit that you have been given to another unit. Especially when you talk about volumes and the pressure. So it is quite tough if they ask you to. But if they don't, you're good to go. So you don't have to be worried. So which one comes in as the right answer? As you are doing that,
147.
yes, 147.6. So the answer is 147. As you are doing that, I want James to tell me there is a problem. Just do it in the text as I wrap. So 147.62 is the right answer. I don't know if there is any question. Is there any question? Sasa tumeelewa combined gas loss. Tumekuwa sawa. Like if that question comes in, you should not be tense. You should not be tense. You should be on a relaxed and don't be in a hurry. Again, I was telling you, when you're using a calculator, make sure you're taking care of some of the things. For example, you can say 2 multiplied by 80 multiplied by 298 divided by 323. The answer will be different. You can try. I don't know. Somebody try. I want you to do this. Multiply 2 multiplied by 80 multiplied by 293 divided by 323. Can somebody try that? What I'm saying to you do is this, so that I explain that one today. I don't know if it will give us if it gives us the same answer, then you're using a very good calculator.
Yeah, it gives us
Multiply
the same.
298. Is it giving the same answer?
Yes, 147.61.
Divided by 323. Then you are using the improved one, the other calculator. Lakini zile za kitambo, the FX82 zile za kitambo. If you do this without introducing this one, what I'm saying is, usipo introduce something like this, ilikuwa inaleta shida. So it requires you to do and then you say answer divided by, when you use the current ones, I think the current ones have been improved because watoto wa sahi wanasaidiwa kupita, sio kama wa kitambo. Those people who did the exam long time ago suffered. Hata kuna topics ziliscrabiwa out from mathematics so that it can help them perform. So the calculator is normally very dangerous. Mimi naogopa maneno ya calculator. This one is what I was saying, that it will change the answer. Yeah. Something like this. If they give you kitu kama hiyo na waseme after you have divided, so unajua chini una multiply, then you multiply by 10. This one will give you a different answer from when you do this. When you close the brackets of the first one and the second one, you get a different answer. Ukiclose na uache nje, it normally brings problem. But when you divide by 1, it is okay. Yeah, I think it will give you something different. We will see in another question, another example. So it is very dangerous for you to use the calculator without consideration. The calculator, I don't know, our calculators are not really computers are better because computers will give you the right answer. I'm not talking about the phone. I'm not talking about the phone. The phone, no. I hope you have understood that one. Let me just introduce something before James, I want you to write what happened. I need to know so that before I continue. But in the meantime, let us do this. So I want to let me just take a picture of this one and then I send it to you. So I'll just share this one. You can try it. This one is a combination of very many questions. So let me just share it to the WhatsApp think I can share it to the WhatsApp, so you can try it as yeah. Let me just give you this one. This one is for combined gas flows. So we have been doing for the rest. I'm going to give you for the combined gas flows, so you can try it. Let me just take a pic of this, and then so try those ones. In your free time also, you can try that. So the next one, after we have known now the Boyle's law, the Charles law, and the combined gas law, and now we calculate them. Of course, when you talk about the combined gas flows, now we'll be talking about in Charles law first, we are talking about interconversion from Kelvin to degrees Celsius and the vice versa. And then now we go to the combined gas law, where it is combining the Boyle's law and the Charles law. We are done with that one. We go to what they call the Graham's law of diffusion. First of all, I was supposed to tell you Graham is somebody, engineer. So before even we go to Graham himself, there is something that we did in biology. So we have diffusion. Now, first of all, diffusion normally occurs only in fluids. Now, when I talk about fluids are this. So mara mingi watu wataambiwa fluids wanasema so it occurs in fluids which is gases and liquids. Plasma it could be because it is a confused element, but solids diffusion is very hard to be noticed because now of the compactness of the particles, which I think it is somewhere here. Lazima that one I must explain using a diagram. Now, so in biology, you say diffusion is movement of particles, molecules, mention them, anything from a region of high concentration of a region, or now this one is saying it's from a region of where it is more concentrated, that is the region of high concentration, to a region of less concentration. So that one is diffusion. Now, if you borrow the idea of definition of diffusion from bio or from other subjects, it is okay because it ends up giving the same meaning. So diffusion basically means spreading out. A very good example. Let me just example. Mtu akiingia your home na anatumia very strong perfume, most probably mtu ako jikoni atasema wa, na huyu anatumia perfume strong. Yeah, that's what people would say. So that one is diffusion of gases, which is quite fast. It is very, very fast. Now, when you go now to other, so we are saying the perfume is moving from a region of high concentration, which is that the person's body or the person's clothes, to a region of low concentration, which is your kitchen. Hata kama ulikuwa unakata kitunguu, you're cooking something that smells nice. Another example is that when you're cooking in the kitchen, the African way, actually, of identifying that ugali imeiva is getting a good smell. I know there's a special smell. Yeah, there's a special smell for ugali, and then it identifies that you're a good cook. Or I don't know how people normally. So that one again is diffusion, where you smell it in the sitting, or if you're in your study, or if you're in another place, you'll say now your ugali imeiva, or somebody's cooking, pilau somewhere. So that one is diffusion. Now, that one is for gases. When we talk about liquids now, I don't want to give a lot of things. When you talk about, of course, you have gases where you have bromine and chlorine, and then there is interchange. That one, this one is something that is done in Form. I think it is done in Form 1. It is done in Form 1. I'm very sure it is done in another class, either Form 1 or Form 2, but a lower class than Form 3, where we have that one. But I wanted to talk about the diffusion now in liquids. Now, the diffusion in liquids is, I normally use what do you call this man now? What is the name? The person when you call 310, what was the name of this guy? 310.
Kanyari.
310, yeah, Kanyari. I normally use Kanyari. Yeah, Kanyari. Thank you very much. Normally use Kanyari. You remember when Kanyari used to wash miguu za watu na anatoa vitu kwa miguu? I don't know. There was a time he used to remove things from the legs za watu. Yeah, Kanyari. Now he used to use potassium manganate 7, which normally produces a color in water. Now, in a small amount of water, you see a different color, which is normally almost purple. But when you add water equal mingi, that means it is between it is not dilute, and also it is not constant. Iko hapo katikati. And then you choose a nice basin. Give an example, blue, even red basin. I think when you choose a basin, it will look like blood, depending now on the color of the basin. So what we're gonna feel. So when you put that one, and then this one again is something that is done in Form 1 physics, and I know everybody took physics in Form 1. So it's normally done in Form 1, the diffusion effect. So unaweka kwa kona a metal, a solid one, not a metal, a solid one. Unatupia kwa kona kwa maji huko, and then you see it is moving now from that region, and then it spreads. After sometimes it will spread to the whole water will have changed color to purple. So that one now is another. That one is for liquids. That one is for liquids. So when we talk about gases, we are talking about the smell that is brought in by perfume, food, and the rest. Yeah. Or people normally identify somebody unasema, hey, we hajaoga for long. Yeah, we normally use that smell. That one is an African style. I don't think it is allowed in other places. So what you normally do is you put water in the beaker, and then you using a tube, a small tube, a glass tube, or a glass rod, depending on that time. Alafu unatupa kidogo. It will spread now from that region until the whole water would have changed. They not normally ask for that one, but I have to tell you. So it will turn purple after some time. So that is moving. That is diffusion. Those are experiments for diffusion of both gases and liquids. I hope I'm not moving too fast, but I just have to tell you those things. Actually, that one is diffusion. Now, if you wanted to explain diffusion in terms of kinetic theory, now when you talk about kinetic theory, you're talking about the spaces, the movement of particles, the spaces between the particles that are making up a solid, the spaces between particles that are making up liquids, the spaces between particles that are making up gases. So we say particles in liquids, in solids, are held so close, so the strong attraction between the particles make them be in fixed arrangement or in fixed position, so they cannot move. They're called lattice. In chemistry, I think the lattice normally comes in Form 4. We'll have something called lattice energy. I think we'll talk about that one. Lattice and hydration energy. I think it is the energy changes. That is the second topic in Form 4. So you don't have to. So they will vibrate on within the same position. So there's no movement. So they might not actually diffuse. Remember tuko tumeongea kuhusu Brownian motion. Kuna pale tunaongelea Brownian motion. That one is the constant random motion called Brownian motion. So, but that one is for another time. Now, liquids, they have moderate forces of attraction between them. So they can move, but they tend to be closer to each other. So that is why the diffusion now of liquids will happen, because they are not vibrating about the same point ama kwa position moja, ina vibrate ikisonga kidogo. That is why you are finding now the permanganate moving from that region, ina migrate pole pole. It will take time, but itafika. Yeah. When you talk about the gases now, there is no attraction, or there is very small attraction. That means the molecules are very, very how much apart from each other. So they will move faster. And of course, now a lot of kinetic energy. Now, there's a formula for calculating kinetic energy. I'll give you, it is half m v squared, so that it becomes easy to understand. Let me just write for you. So Ke, which is the kinetic energy, is normally given by, I'm just giving you this one, half m v squared. Now v is velocity. Now I will tell you there's something called energy of conservation. I don't know. I think we mentioned energy of conservation somewhere. I don't know if it was this class or another class, but I did mention energy of conservation of energy. Now, in energy of conservation, in the law of conservation of energy, we normally say energy can neither be created nor destroyed. So most of the time, you'll find that kinetic energy will be converted to potential energy. It will be converted to electrical energy. Those ones. So it doesn't matter. You can still calculate, and this one is mass. Now, and these things, they're normally so because the velocity of the gas particles is very high, the kinetic energy, of course, becomes very high because of that distance. So it will be moving very fast, and that is why now the diffusion in gases will be higher than in liquids, which is also higher than in solids. That is why the first statement that I mentioned when we talk about diffusion, we said in solids, it is very hard for diffusion to happen. For example, ukiweka mbao na uweke chumvi juu ya that mbao, how long will it take to reach, even to move by 1 centimeter? Can you taste salt in 1 centimeter or even 1 millimeter in that wood? No. Lakini uleta mafuta. I'm not talking about the petrol. I'm talking about any liquid. Yeah. Na weke kwa mbao. How long will it take ifike the other side? Or water. Let me use water because water is easily away. Okay, ukileta mbao imekauka na uwekelee kwa maji hivi, the tip, how long will it take for the water to reach the upper end? It will be fast. Yeah. And diffusion is very important. So we'll be talking about the importance another time, not today. I don't think it is in this class. Now, so that one is how we show it using the so if you have to explain diffusion using the states of matter, you use this one. What you can even you do the drawing, it is better to have this drawing. This drawing will help you. You write solid, this one liquids, and then you write these ones as gas. This one will help you in the drawing. Kama tumeelewana. Now let us continue. So there's something I wanted, but I don't think we are going to. So the rate of diffusion is the rate at which let us just finish here for today. There's something I wanted us to start, but I don't think we are going to make. I think we overstayed in the other part. So the rate of diffusion of gases, of course, when we talk about rate, anytime you see, I think I had mentioned this one. Anytime, or I mentioned it in my other class. So the rate, time wanasema rate, jua time iko. Anytime they say rate of something, they'll say the rate at which you are eating this food is not good. The rate at which you are driving this vehicle is not good. That means they're saying you're doing something, whether within a very short time or within a very long time. So rate normally affects the. So an experiment to investigate the rate of diffusion normally done again in Form 1. It is we normally use hydrogen fluoride. It is also done in Form 2. But I think in Form 2 you are testing of something else. You are testing of RAMs, or the relative formula masses, or the weight, the masses. So the rate of diffusion is measured at which the quantity of a gas. Or when you talk about quantity, we are specific now. We are talking about amount. The amount, it could be 10 liters, can pass through a certain space or can diffuse. We normally say in biology, is it permeable or semi-permeable? Membrane, the semi-permeable membrane or the semi-permeable body at a particular time. That is why nilikuwa nasema hii rate, anytime you see rate, wewe jua tunaongelea nini? Time. Time is being affected. So to investigate that, we normally use HCl, which is hydrochloric acid. Actually, it is hydrochloric acid that produces hydrogen chloride gas. So what we do is we dip a cotton in HCl, and we dip another ammonia in HCl. We dip another cotton in ammonia liquid na tuweke tu kwa pipe, and then we wait for the observation. Now, I don't know if time will allow. I don't know if time will allow us, because it is already time, and I know people are very tired. I know you're very tired. Are you tired, or can I finish this one? If you are tired, it is better to start from there, because I can finish this one. Moura, how are you feeling? Monica?
Mwalimu, let us stop there, then we continue. We are tired for
So
real.
we continue. Yeah, I know people are very tired, and now ilikuwa maneno ya job, but then it is in the evening. And now, but at least we have understood the calculations of the first laws now before we go to the other. We have other calculations. So let us prepare for other calculations. So when we meet, I wanted to go and continue discussing about this one. We can continue discussing about the diffusion in terms of yeah, it is okay. It is okay. I don't want to teach people who are tired also. So why don't I wish you a very nice evening, have a very beautiful night sleep, and then have a very beautiful week ahead. I think that is all.
Good night.
You have a very good night. Yes. And bye bye.